I forgot to say. So the title of the talk is The First Step to Efficiency, how real-time monitoring prevents equipment failures and reduces energy waste. As an aside, earlier we were talking about reliability, energy efficiency, how they go hand in hand. Boy, this is going to be a timely topic. So Evie Hunt is the founder of Terra Viva Energy, a company dedicated to optimizing energy efficiency through advanced real-time monitoring and analytics. With a background in electrical project management, including the installation of renewable energy systems such as wind and solar, as well as energy efficiency technologies. Evie brings a unique blend of technical expertise and strategic problem solving to the energy sector. Passionate about sustainability, Evie believes that energy efficiency is the foundation of smarter, cleaner future. Her work focuses on leveraging the Internet of Things, big data, and artificial intelligence to help businesses reduce energy waste, lower operational costs, and improve equipment reliability. She emphasizes energy monitoring as the first step towards achieving sustainability goals and collaborates with organizations to reduce their carbon footprint while improving operational performance. Committed to sharing knowledge, Evie empowers businesses to take control of their energy use and make data-driven decisions that drive long-term success. Floor is all yours, Evie.
Hello, how are you guys? As you mentioned, my name is Evie and I'm with Terra Viva Energy. Um, I did come from the commercial electrical background. And so one of the things that stood out to me when we would do the renewable installations or the lighting upgrades is that after you do all the calculations, you apply for the rebates and you have this projected amount of return on your investment that you're supposed to get. But once those installations were done, there wasn't always a great way to verify that you were getting the return that you had invested in. So we definitely saw a gap in that model. And that's why I'm so excited of what we're doing here at Terra Viva, because now there's no guesswork. We know exactly what your energy spend is, and we know what assets are using it. So with that, let's continue. So we all know what this is, right? You're out of gas. Okay. So if this has happened to you, it's not great. But let's say you jump on and go to the gas station, fill up your gas tank, and then you get on the highway and then you run out of gas. Well, that's a totally different issue than planning. You must have a leak somewhere, right? So if you're leaking gasoline like that, then most likely you're leaking energy like a lot of companies are leaking energy. Companies lose up to 43% of energy to avoidable waste. So that's energy that they're paying for, but they're not getting it in any useful form. So they're seeing the high costs, the peak demand charges, and system inefficiencies, but they're leaking energy in hidden equipment, running after hours, inefficient compressors, phantom loads, and poor scheduling. So how does your building compare? Do you know how much you're wasting of that 43%? So remember, we're out of gas. So you find some kind soul that helps you to get to a mechanic, right? So hopefully you're in good hands. But what does he say? He says you need a bigger tank. Now that seems absurd, right? If you're leaking fuel, you probably have the leak, you need to address that. But a bigger tank, the reality is that it probably could get you a little bit further down the road. I had a guy that I knew one time that he would make regular trips to the valley and he didn't want to stop for gas. So he literally had a 50-gallon tank added to his truck. So he never had to stop. I never knew what he did for the bathroom. I didn't want to know. And so this is kind of how some companies approach that idea. They're not looking at the leaks. Instead, they just try to add more generation, solar, wind, or upgrading their equipment. But if your tank's leaking, adding more fuel doesn't necessarily solve the problem. You're just leaking more. So that's when we can see, even though you have a bigger tank, you're going to be disappointed in the long run. And this is what happens with some of those when they're not monitored. Solar projects since 2015 are delivering 7 to 13% less than financing models assumed. That equals a week of lost generation every single year. Wind, 1 in 3 is underperforming its P50 forecast by at least 15% in the first 3 years. It's like paying for 12 months of fuel and you're only driving 10. And an audit by ABB of over 2,000 industrial motors had an average of 31% avoidable energy draw in the upgraded systems. So we changed the tank size again, but we never fixed the line. So this isn't, as you can imagine, this isn't a resource issue because the sun is still shining, the wind is still blowing. This is a visibility issue because there's nothing showing us that we need to fix those things. So this is the principle that's kind of driving our conversation today. Energy efficiency is the first fuel, the only fuel that grows when you measure it. And that's by Dr. Fatih Birol, who's the executive director of the International Energy Agency. Their net zero pathway has 40% of the CO2 cuts just from efficiency. That means no new hardware and no upgrades. And if you want to read a little bit more about that, that QR code will take you to that net zero pathway. And so if we want to look at it in comparison, the average cost to save a kilowatt is less than 3 cents. So it's cheap, but then people will gladly pay for 4 to 6 cents for some renewable energy. So this is how it stacks up energy efficiency when we look at side by side to those other systems. Energy efficiency, we can see, is the cheapest, it's the fastest payback. And so really we need to start thinking about it as the benchmark. All of these other things that we can do are solid investments, but this is what every other investment should be measured against. So every watt we rescue from the funnel is a watt we don't have to buy, burn, or finance. That's the first fuel that we're talking about. So we made the case, why should we produce more when we're wasting what we have? But sometimes in energy efficiency, they might tackle it the complete opposite. You may know somebody, we're going to save on energy, so we just don't use the resources that maybe our operation needs because we're cutting back. So I found this comment because I thought this would resonate with the Texas audience, because we know that any amount of time without AC is a nightmare. So we don't want to cut back. Energy efficiency is not about going without, okay? It's about using the energy that we already pay for, but just in a smarter way. And what kind of got me on this thought was that there's a county of Durham, in a Walsingham school in the UK, and they had the great idea of a Blue Nose Day. And they'd sent a letter home to all the parents and said, send your kids to school with sweaters, wool pants, mittens, and gloves, because we're not going to turn the boiler on because we want to reduce our carbon footprint and we want to save energy. But really, that's not the way to do it. We don't want to go without. We want the kids to put their sweaters away and enjoy. We want to raise that importance of being more sustainable, but in a responsible way. So if you want to look at that article, it's pretty funny. It's the QR code is right there. Okay, so whenever an energy bill goes north, organizations can swing to those one or two extremes. But there's a smarter option that's right in the middle, and that's monitoring and optimization. So here's a report by Siemens, and they listed the top 10 energy saving options. And if you notice, monitoring and targeting are at the very top. And it's not just that it's the top, but it's the fastest. Nothing else even comes close. Even the next one is up to 12 months to get a return. And this is what they had to say about it. It says an effective monitoring system is typically the most important element of any energy management program and will deliver the fastest payback. So what does that look like in a facility? So here we have like a stylized version of like a factory or some type of facility. And so we see all these little beacons here. They represent certain equipment. So the blue one that we see there, that is a compressed air. So you're losing $3,000 every year with just a 3 millimeter leak in a line. The next one is a steam trap. If there's a little bit of moisture coming out there, you're looking at maybe $6,000 annually that you could be wasting. And this is not data that shows up on anything. Okay, you don't know it's there. You just know something's costing energy, but you're not sure where. The blue is a cooling water pump. If there's any type of wear on the impeller or a failing seal, then the motor draws more current. But the key is even just a 10% rise in amperage will signal the maintenance team that there's an issue if you're monitoring it. And then the yellow and the blue, those beacons represent like a forgotten HVAC system in a lab that nobody's using, or warehouse lights that are popping on at 2 a.m. in the morning and nobody knows that they're on. Each of these beacons has a unique energy signature. And when you have the baseline and you're monitoring them regularly, they jump out immediately. And that type of clarity allows you to pinpoint leaks and eliminate the guesswork. So you can predict when maintenance is needed, but you can also avoid any breakdowns without seeing them coming. So I think I have to do this manually. There we go. So this is a lot of people in the industry are thinking, well, we have a SCADA. So we see all this data, and we talked earlier about all of that historical data. But remember, SCADA is really, really good at controlling your processes, but it's not looking at energy efficiency and it's not looking for waste. So when we look at this dashboard here, this is what we're talking about with monitoring. We're talking about live electrical behavior, cost overlays, and AI-driven alerts. So if you think about SCADA, it controls your processes, but versus accountability, monitoring shows you what's going on in your building so that you can change your behavior based on what is the most energy efficiency or tackling some of those maintenance issues. It stops at the PLC. So if an asset isn't tagged, it doesn't exist in the data. SCADA doesn't see it, but it doesn't mean it doesn't exist on your electricity bill. You're still seeing those high costs, even though you're not line iteming that item. It catches ghost loads because SCADA rolls that data up in 15-minute chunks. We're talking about second by second being able to see that. So we're going to see those tiny little spikes, those base load creep, and we'll know immediately when something's not behaving according to the baseline. To make any changes with SCADA, it requires engineering hours, new code, so it's not easy to plug and play. The endoscope monitoring system, it installs non-invasively and it starts delivering insight immediately. And you never have to touch a PLC. And then the ROA that we're talking about, it's hiding in the gaps. And that's not something that SCADA is looking at all. So we're sampling all of that and we're registering it per second. And those hidden savings are what's going to pay back the fastest. And that's what we're seeing with monitoring. So what does that look like? How do we achieve that? So we have three different pillars. The first is the hardware. It's a mesh network of IoT sensors. We use CT clamps along with edge devices, and they communicate over a low raw network without Wi-Fi. So you don't have to worry about that. And then we have software, a cloud native analytics engine, AI-driven anomaly detection, custom rule engine that delivers real-time alerts and dashboards that are user-friendly. And then if you don't want to look at that data yourself, maybe that's not something that you are interested in, we have available a 24/7 virtual energy management team that is dedicated to monitoring those alerts, investigating those deviations, and giving prescriptive recommendations. So it's really a closed loop system that measures energy, targets waste, and identifies the savings. Here's the architecture. It's an end-to-end feedback loop. So we can see how the devices over there, let's see if I can get this to work. Those capture the temperature, the current, occupancy, the pulse count, the data, and it's all transmitted over the low raw network, which is, well, let me see. It all is transmitted to the hub, which is the endoscope right in the middle. And I think the indoor range for that lower network is like 300 meters. And so it's got quite an extended. And it pushes data up as a default at 1 minute interval. to the cloud. And then the cloud is where the real-time analytics and anomaly detection take place. And then it has those custom rule engines and AI alerts that fire immediately when something drifts out of baseline. So you can use our dashboard, which is very, very user-friendly, or you also have the capability, if you have your own platform, to pull that in via API, as well as send commands through that same API system. So this right here is the architecture that's delivering the cheapest kilowatt that you'll ever generate. So how does this work in the real world? So here we have a laundry system in a hotel. And you can see when we started monitoring, it wasn't even that long, just a couple of weeks. They noticed when they took all the assets and they did an estimation of if they were all running full, how much energy consumption they should be having. But the actual consumption was just extremely high compared to what it should have been. So that meant something was going on. So after investigating, there was a few things that stood out. First of all, they were leaving equipment on after hours. And then machines were running at 10% capacity, just putting a little bit in and running it, but it was drawing full power. So that took some duty cycling and behavior changes, but you would never even know that you needed change unless you saw that data. So just with that little bit of changing, I think they got at the solution was to get baskets that actually had the volume of a full load, and just simple, just make sure you're loading it at 100% before you run it. The other thing that showed up, which I thought was interesting, is they had this energy being drawn from the laundry room with nothing that existed in the laundry room. So they had to figure out where that came from. And the truth is that there was circuits from a retrofit that nobody there at that time even knew had happened, but they had never disconnected those circuits. They just deaded them. And so they were still pulling that energy, even though they weren't feeding anything useful at all. So we can see from this case that visibility leads to accountability. Now they know that their behavior can make a difference. And once they have that information, they can change that behavior. And then over the time, you can see they had a little uptick in their consumption because new assets were introduced, but right away they could see that it needed attention and they were able to drop back down. So with visibility, you can sustain those savings over the long term. So we talked a little bit in the other case study about zombie loads, and that might be something that you're not familiar with, but as coming from the electrical side, that's something we saw all the time, just layers upon layers of old wiring in the walls. And these are like zombies that are lurking behind every walls of most buildings. They're power drains that are completely invisible, and they come in the form of lighting ballasts that are left energized after an upgrade. That's like $30 to $50 a year. Maybe HVAC controls that are disconnected, but they're still powered. So that could be $120 a year. Bypass VFDs, decommissioned motors, they're all still wired. Idle panels and junction boxes that are still live. And then an empty server rack with switches. They're still drawing standby power, and they're costing you $150 a year, but serving no useful purpose. And so individually, all these things may not seem so scary, but imagine these things across a building portfolio or a huge campus, and it adds up to thousands of dollars that you're not getting any use for, but you're paying that energy. But the truth is, if you're not watching for every kilowatt, you'd never know that they're there. Here we have a plant, a cement facility, and they had 150 motors that were all aging. Okay, so I don't know if any of you know what that feels like, but you're depending on those motors for your operation, and you know that if one of them goes out, it's gonna prevent your operation from functioning the way that it should. But you also don't want to replace it prematurely because you want to get the most value for that. But they had no visibility. They had escalating energy bills, but no way to tie them to which motor because they had no sub-metering. And so where they were at was they were considering a huge capital expense to just replace all the motors at one time because of the fear of critical failure. That's what had them worried. So what we did was we installed basically in different sections of those motors, the CTs, and then they were able to rotate those to all the motors until they mapped all energy signatures of 150 motors. And then they found a few things. They detected scheduling errors, also phase imbalance. They had motors that had 3 phases and only one phase was pulling the draw energy and the other two were doing nothing. Well, that signifies a winding failure or a loop connection or a VFD malfunction. So those are the ones that they knew they had to put attention to immediately. And so motors are the biggest power consumer in most industrial facilities, and they have the greatest potential for savings, but also the greatest potential for risk. So there's a lot of value to monitoring them to see not only when you have to replace them, but also when you don't have to replace them, that they can go a little bit longer. Here we have a car crusher at a recycling plant. And it's interesting because if you look at each of those little blue plateaus, each of those represents a crush cycle. And every single one of them is pinned at max amperage because of course 100% does the job, right? But once they turned monitoring on, it got them to consider the possibility, what happens if we dial that back 65%? What's the outcome going to be? And so that's what they did. And they could see the outcome was that they still had the same cycle, the same throughput. They got the exact same action that they needed, but they saved 40%. Their energy draw went down 40%. Well, that's $75,000 that they saved annually. Can you imagine saving that just from making a simple change on a dial? And imagine the lifespan of that equipment. You're running it at full speed and you tack it down. You're not going to have to replace those components for a lot longer because you're not running it at full speed. And so really that monitoring system was paid back in just 8 hours. I don't think there's many ROIs that you can get in just 8 hours, but monitoring compared to the other ones, it's such a small investment, but the payback is so high. So this is a metal foundry, and they operated 5 big, huge screw compressors that were running around the clock. But when they finally hooked up monitoring, they could see that the demand peaks that they had never required more than 2 machines. So they had 3 huge compressors that were literally just hidden current and just costing them. So once they were able to use the equipment accurately with their real needs, and then they also were able to find the leaks and tackle those. They had 42.5% compressor energy cut in 5 months. They saved $67,000 and their ROI was returned in less than 1 year. And they had a 50% CO2 drop. And what's great is that phase 2 was greenlit because they had such great success just monitoring those compressors, that now it's underway. They've added 4 more endoscopes. They're monitoring the lighting and the ovens and all of their motors because it's addictive. Once you can see the kilowatts, you want to see them all because what else can they show me? So if we think about sustainability goals, whatever it is, we all have them for our organization. They're really a journey, okay? And we have to get there just like we go to any destination with a roadmap. But the truth is that the only way you can plot a destination is if you know where you're starting from. So like a GPS that doesn't have any kind of location signal, that's where a lot of people are operating. They're trying to get to these goals, but they actually have no idea where they are currently. But that's what monitoring does. It shows you exactly your live location in energy terms, your baseline, your drift, and your trends. It allows you to adjust course in days, not years. So before you spend thousands trying to jump to step 4, let's make the first step solidly with monitoring. So generally, TerraViva, what we do is we monitor 5.7 billion data points collected in over 70 countries. So we can take just the review of your bills and then your floor area based on some of the systems that you have, and we can have a really good benchmark of where you are, how much waste, a projected amount of waste, and also what your potential savings potential is. And then starting from that point, we can have a great idea of a roadmap to get you to your first 20% of savings. So that's something that I'd love to talk to everybody about your specific pain points or what your concerns are. So this is my contact information. If you'd love to start that conversation, I'd be happy to talk with you. Oops. Thank you. Enjoy your evening.
Perfect. Okay, we have time for a few questions.
Oh.
Right off the front.
Yeah.
Eva,
Yes.
when we have done these kind of surveys, one of the things we find is that the measurements are missing on much of the equipment. So how do you address that issue?
Well, so when you say survey, that makes me think of like a snapshot of the energy at that time, like an audit. Is that kind of what you're talking about?
Well, an audit to justify putting in a real-time monitoring system.
Well, I mean, the data just, it doesn't take much. So you can do like a proof of concept sometimes on one piece of equipment that is, that you want to see it is, and then you could see right away immediately what that current is drawing. So, I mean, that would be my answer to you, is that it's not a snapshot. You're seeing it continuously. So you can see in real time what the changes would do.
But what I was saying is the actual device lacks measurements of the current or of anything
This
else.
is a partner of mine, and he might be able to answer.
Okay. What?
Oh, you have the mic.
I want the people online to hear. Yes.
Hi, my name is Azar, and appreciate your question. I think you are absolutely right. A few years back, the technology was new. This monitoring systems have been out there for a few years, and the issue around the missing data and the accuracy of data has been an issue over time. But what we have seen over the past few years is that the quality of equipment in terms of technology advancements and stuff is improving by every passing day. 5 years ago, 7 years ago, we used to see this as a significant problem. Like system after system, you'd see data points missing and accuracy of data is questionable. But I think where we are sitting right now today, it has improved a lot. And it's a journey. We're not 100% there yet, but the quality of data management, data readings, measurements, the percentage of missing data, just like if you look at any other industrial instruments, right? Spurious trips have been one of the big industry concerns, but it's improving. Oil industry in general loses 2% of their overall worldwide production from spurious trips. So it's improving. I think the accuracy of instruments has been an issue. But what I can see today, based on some of the feedback that we get from around our customers and some of the peers, we hear a lot less complaints about the accuracy of data and the recommendations that come out of the system. Yes.
Same. The stuff I've read on their work is electrical system monitoring, and that's a key. That's a new.
Water and we do all sources. We do water, natural gas, but the fact of the matter is that power is the most expensive commodity. So we focus on power. In some other parts of the world, water is very expensive. So, but the system has the capacity to interface. It's a pulse monitoring system through pulse meters, where we can interface for natural gas monitoring, compressed air. That Evie touched about the leaked air from air compressor, which is a big problem in the industry. So yeah, the system does have the capacity to monitor anything and everything.
And you're setting a baseline. So once that baseline is set, it's like, even if you don't know exactly what you're looking at, something's out.
Learning stuff every day myself. Another question from the back here.
So sort of following up on that discussion you were just having, have you looked at many plants like oil refineries and petrochemical plants, because those tend not to be so much electrically dominated. And that's what I guess the majority of the people here are more familiar with.
Mostly it would be, they still have equipment, they still have motors and compressors. And so that would be the energy draw that would be looked at. And lights, I mean, lighting is a big thing, HVAC, all of those things waste energy.
I'd like to follow up on Alan's very, very great comment. And also I want to thank you for a wonderful presentation and really opening our eyes for something very important. And I just want to quote one of my colleagues in one of the distillation symposium. His name is Ross Vale. Some of you may know him. He's from Marathon. And what he was saying is that if something doesn't look right, it probably is not right. Okay. And this is something for all of us, chemical engineers. You asked about chemical engineers. Look at your plans. If you see something that's not right, it probably isn't right, and follow it up by monitoring that the same way as you mentioned. Your chemical engineers will know how to monitor each phenomenon. And once you monitor that, you can really find out what's not right about it and take some good care of that. But this is a very important point, and this is the place where, and I want to bring another example since Jim was giving a beautiful class out here today. One of the things he was showing us is he was showing us all these steam traps that were belting out steam or something like that. And you look at it, hey, these things should not have been belting out steam. They're there to remove condensate. What are they doing belting out steam? You know something is not right. And this is, and again, he was putting it into dollar values, how much it was. And so, again, things like that. So again, and this is, and hey, these days we talk about decarbonization. We're talking about the survival of our planet. That's really what we're talking about. So let's look for things like that. Let's do the monitoring, exactly what you're saying.
This is the easy stuff. That's the thing, is all those other things that come after, they're all great investments. But if you start with monitoring, that's the first step. And then you can keep adding on to that, keep adding to those investments, and then see the return because you're monitoring it.
Sometimes it's not even investment, it's repairing something that's not working properly, just like you outlined. Okay, thank you.
Thanks, Henry. Oh, okay, Jim?
So actually, one of the things I liked most about the presentation kind of skipped over on the compressed air side, because you showed like a $67,000 savings, mostly from the leaks and shutting down 3 of 5 compressors. But compressors that run under capacity, you're suffering from the motor affinity loss. So that's a big difference on the load change. So, and you see how that affects ratchet. I don't know if you take things like ratchet and all that kind of stuff into play, but I think that's more money in there. And the other thing I notice is on the steam traps, it depends on the site. Like in New York City and Connection, it might be $6,000 a trap, but down, like in a refinery, it might be $1,000 or $1,500. So, or whatever it's worth, it depends on the site. But I think you got a lot more there on that compressor side if you look into it some more.
Okay, I think we have some questions online. So just let me slip over here.
Where do you see the best saving opportunities around behavioral changes or technology changes? From Thomas Boudreau.
I think it's a combination, but it definitely, a lot of it with behavior, because if you don't, I mean, everybody knows that you shouldn't leave the lights on when you walk out of a room. But if you had to pay $20 every time you walked out of the room and left the lights on, then all of a sudden it makes an impact. And so with visibility, you're actually seeing what those things are costing you. And so it definitely is a motivation. And also without a lot of times we can do audits like we talked about, but those are snapshots. And unfortunately, the tendency of human behavior is to drift back to our old habits as soon as it's out of sight. And so that's why we advocate for continuous monitoring, because then you're always watching. So if something drifts out of that spec, you're bringing it back. So you're constantly focused on that. But then also, repairing equipment, upgrading. And then when you do make upgrades like the lighting or the renewables, you're really getting the accuracy of how much you're producing, what hours you're producing, if it's in peak or if it's out of peak. Those are things that you don't necessarily have a real handle on unless you're monitoring.
Any more questions, or is everyone trying to hit? Oh, okay.
So just sharing a story based on the presentation that was made about fleet monitoring. One of the things that I observed, because I was heavily involved in developing the tools, is in psychology, there is a concept called social proof, right? It's like when you go to restaurants, you go and look up, okay, which restaurants have a 4-star rating? And then you go to the restaurant. So by going and taking that fleet monitoring data and sharing it across the enterprise, that led to people going in and calling up the most efficient energy site to go and say, hey, how are you guys operating your furnaces at 80, 90% efficiency, and why are we still at 70? And that led to a dialogue for sharing experiences and maybe exchanging folks, going over to the other side and say, these are where your energy is leaking, so go fix it. And like she mentioned, that's the cheapest way to save energy and improve efficiency. Just wanted to share. Sorry? Oh, GEMS is a whole system. So no, GEMS was a process. Okay, it was Global Energy Management System, so it was a process. We started out in '98, and then we were able to get 10% improvement across the mining and chemicals. And then by that time I had moved on, and then back in 2011, they called me back into that role where I started and said, okay, now that we have gotten all the improvements that we can, how do we go and sustain it? So the fleet monitoring tool was part of the sustainment. But that led to a lot of these things, going and finding out cheap solutions. To just go and say, for example, another story that I might be able to share is while I was developing the tool, we were going and looking at air preheaters. And I went in and said, okay, a really good rule of thumb would be to go and say, if the air temperature going into the furnace is greater than, pick a number, higher than ambient temperature, then the air preheater is working. With that simple rule, I was able to go and detect that some of these air preheaters were not working properly, where the site thought that they were working. So we were able to call them up and said that, I'd never been to the site, or, not to name the site, but I just called them up and said, look, my analysis based on your historic data is telling me that your air preheater is not working. You are telling me it's working. You better go and verify it. So the guy goes out in the field, verifies it. Similar thing happened when I was reviewing furnaces, and there was a big hole in it. And I went in and looked at the data, and I was able to go and said, there's something doesn't look right over here. Can you go and check? This is in an energy review, right? So the contact engineer goes and checks, and yeah, there was a hole over there that we didn't patch up. Yeah.
I think that I do want to touch on that point that you made just about the community involvement. There's a municipality in Massachusetts, and that's one of the aspects that they're really interested in, because the way that you can display the data once you bring it in with Enoscope is it's very easy to understand. And so they've got an initiative across their whole city of energy efficiency. And so in all their public buildings, they want to be able to show how much energy each one of those buildings is using and what the carbon footprint is. And it's something that the whole community is getting involved in.
Okay, so anything else? Any more questions? Going. Thank you very much for an enlightening talk. Appreciate it.